A lawnmower company purchases wheels from the supplier Wheels R Us, which claims that less than 1.5% of their wheels has any kind of defect. The lawnmower company purchased 10,000 wheels and examined a sample of 150. Out of the 150, there were 2 that showed a tread defect. Estimate the true proportion of wheels that have these defects using a 95% confidence interval. Well, instead of approaching this as we have before, I noticed that the population percentage is very small, or estimated to be about 1.5%. So when we sample, we're bound to get a very, very small value for our sample percentage, very close in this case to 0. If it was also one that was very, very close to 1, we would have the same caution. But this one's very close to 0. So I'm going to use the adjusted confidence interval procedure and the formulas for that. So in that, we're going to calculate, instead of p hat, a p tilde, and build our confidence interval around that. Our standard deviation for the sampling distribution will also be based on p tilde. P tilde times its complement over the sample size plus 4. P tilde is calculated by taking x plus 2 over n plus 4. Now, if we were calculating the sample percentage, that is x over n, and we're talking about 2 out of 150, so that's 0.013 approximately. Now, p tilde, x would be 2. The sample size would be 150 and then add 4. So I have a ratio of 4 over 154. So 4 divided by 154 is 0.02597. So to build my confidence interval, I have 0.02597 plus or minus z alpha over 2. 95%, that'd be 1.96, and then the square root of 0.02597 times its complement and divided by the sample size, 150 plus 4. So calculating my margin of error, I'm going to get 0.02507. And then adding and subtracting these on the lower end, 0.0009 to 0.05104. So I have 95% confidence that the population percentage of defective wheels is under 5.1%. Now their claim says that it's less than 1.5%. Our confidence interval shows with 95% confidence that it's under 5.1%. So there is no contradiction there. Now one last thing we can point out here, that if we built the confidence interval as before, we would have had 0.013 plus or minus 1.96 times the square root of 0.013 times its complement divided by 150. And our confidence interval would be 0.013 plus or minus 0.018, and that would give us actually negative 0.005 up to 0.031. And of course, negatives here wouldn't have any meaning to us in this particular situation. There's no negative percents.